Hi, I'm Daniel. I'm a developer advocate for Teradata. Today, we are going to build together a product recommendation system in ClearScape Analytics Experience. I'm very excited today because in this video, we are going to cover a lot of foundational concepts about generative AI. After watching this video, concepts like vector, embedding, cosine distance are going to start to make sense. Accompany me and discover how Teradata Vantage Cloud and ClearScape Analytics Experience will help you deliver recommendations that are relevant to your customers and that can be trusted by them. To access this notebook, you need an account in ClearScape Analytics Experience. Go to Teradata/Experience, fill up the form, and you will get your account. Once signed in, you can see the dashboard and you will need to create an environment. When you create an environment, take note of the password that you choose since this is important for running the demos. Click on Run Demos and you're going to be taken to the Jupyter Notebook environment. Here, go to Use Cases and look for the recommendation product folder. Inside that folder, look for the Recommendations OpenAI Python notebook, which is the notebook that we are going to be demoing today. In this demo, we are going to utilize embeddings and cosine distance. These might seem like overly complicated technical terms, but in essence, they are not difficult to understand. An embedding is nothing more than a list of numbers that is able to capture the essence of a word or a string of words, taking into account the broader context of that word or a string of words. Through an embedding, you would be able to represent words like butter and cheese as a list of numbers and hence the name vector. If you reduce the dimensionality of that vector to something that we can visualize, then you could graph the direction of those different vectors and the angle between the lines that represent the vectors will tell you a lot about the relation between those words. For example, that cheese is more similar to butter, but is very different from chocolate. And that sauce, because there is chocolate sauce, then is closer to chocolate. As a summary of what we're going to do in this demo, we are going to get a data set that includes product names. Then we're going to retrieve embeddings related to those product names. And we are going to calculate the cosine distance between the vectors that represent each of the products. At the end, we are going to take the products that are closer to each other as recommendations when we choose a related product. Also, it is important to note that the creation of embeddings, though you can make it in your own environment and for your own data, can be accelerated by calling available APIs such as OpenAI API or Hugging Face APIs. We have examples in this demo about how to use the OpenAI API to get embeddings. The process, though, is very lengthy, so we in this notebook have already retrieved those embeddings for you and you can use them directly. But of course, if you want to go through the entire process, you can do that by yourself, also following the notebook. When we perform the recommendations, we are not doing it to the entire data set because that also will consume a lot of compute and will be very lengthy to execute. We are taking a sample of 10 products that we are going to get recommendations for, so we have more manageable matrices of data to work with. Having said that, let's get our hands dirty. Let's start. Here we have the option to install the requirements for the OpenAI API, which I'm not going to be using today because I will be using the embeddings that we have already downloaded as part of this notebook. So I will start with the step 1.2. Step 1.1, though, is very important if you want to run the calls to the OpenAI API as related in the step 4 of this notebook, but I'm not going to do that because it takes too much time to do it real live. So I will start by importing my libraries. This is done, And of course, I need to connect to Teradata Advantage to get access to my database. I will input my password. And this is the reason I told you it was very important to remember the password that you choose when you create your environment. This is needed for all the demos. And I will not save the password. I know it very well. Now we are going to get the demo data, which I talk about, that refers to product data from a retailer. I have already downloaded that, so this one runs very fast. And I would appreciate if you can run this optional step, which let us see the status of our databases and tables and give us some visibility on our demos. Then let's explore the data. This is very simple. We have some public available data set, which is the Instacart market basket analysis, and we are going to examine the products table, which is the one that contains the product names that we are going to create embeddings for. So we have chocolate sandwich cookies, all season salt, and everything that you can see here. As you can see, it's almost 50,000 products, which is quite a lot. Now, we have a step here of analyzing how many products we have per aisle. This illustrates very interesting capabilities of visualization that you can execute to get a better visualization of the data, but is not really relevant for building the recommendation system. It's just a data exploration step. Now, we are going to get to the interesting part. We are going to generate embeddings, and you can do that in two ways. You can generate your embeddings and wait for it. I would recommend that you follow the suggestion here that you generate embeddings for 50 products to start with, because if you generate the embeddings for the entire basket, trust me, that's going to take a little bit of time. Since I don't want to generate the embeddings real time here, I will skip, and we are going to assume that we already got them. So we go to section 5, and we are going to walk through this code. What it is doing is displaying the embeddings if they were generated, and if not, just skip it. This code over here is downloading the embeddings that we have already stored in our instance here, and we have them in a Parquet file already. These were already downloaded from the OpenAI system. And we are going to use their data capabilities to read Parquet files to put the contents of those Parquet files into Teradata Advantage tables. This also illustrates that you can use your Teradata database to keep embedding records, which is very neat, because then you can do a lot of the things that you love on Teradata on your embedding store. So let's check it out. So this one is getting the product embeddings, and the other one is taking something that is called search product embeddings. What it's doing is just creating these two tables and giving you some instructions in Markdown, telling you what is going on at each step of the way. Now, I would like to illustrate a little bit to you what happened here and how those tables that we just created look like. For this, I will create other cells here that we don't have to show you the contents of the tables. View product embeddings is going to be equal to data frame of product embeddings, creating that one. And we are going to create something very similar related to the view search product embeddings, and we're going to call it search product embeddings. I just want to see what are the contents of these specific tables over here. So let's do it. We are going to check the view product embeddings shape, and you can see here that we have about 6,000 products with about 1,500 columns. It's quite big. And then we're going to do this search product embeddings, and we're going to get its shape as well. and that one is only 10 rows with the same 1500 columns. So what is going on here is that we are not getting the embeddings for the entire data set, as mentioned, because that will be 50,000 records, so we're working with a little bit reduced data set here in product embeddings. And also, when we get the vector distances, we could do it using this data frame against this data frame itself, and we will get the vector distances for all the products as relation with all the products, but that will be a matrix of 6,000 records times 6,000 records. So in this case, we try to reduce it, and that's the reason we have these search product embeddings that's only 10 records. So we have the products that we want to get recommendations for, the search product embeddings, and the set of products that will be recommended, this product embeddings table. Now let's check how the data looks like. The structure of the tables is actually the same. If we view the columns here, we can see that we have product ID, product name, the aisle, the department ID, and then everything there is embeddings. So we are going to see how it looks like. We are going to capture only the first columns. And here we are capturing the first columns in order you can see how the data looks like. We have the product name and we have the embeddings. I'm showing only 2, but remember there are more than 1,500 columns that are only embeddings representing the context of this specific string as related with the model where we got the embeddings, which is a model from OpenAI. After we've got our embeddings in this table, we can proceed to generate the vector distance and identify what products are similar to other products. And for that, we have defined this function here that is calling out a Teradata ClearScape analytics in database analytics function, which is vector distance. And this vector distance function will calculate these distances for you very easily. In summary, you need your target table, which is going to be the 10 products that we want to get recommendations for, and you want to get your reference table, which is the reference where the entire universe of products that we have embeddings for has been stored. Those are like 6,000 products. As a note, you could have done it with the same data, but in that case, the matrices are going to be not suitable for this demo. And you define also your distance measure, which is cosine distance. And this top K is just defining how many of the top records, that means the ones where the distances are lower, you want to retrieve, then your tables, and that's it. This is a function that we have designed to provide those parameters in a single call, and then we call it from the Teradata engine. What we are seeing here in the embedding column names is that we are just by shorthand referring to records of the columns where the embeddings start from the column of index 4 onwards. So 0, 1, 2, 3, index 4 onwards to the end. Then the number of recommendations, we are going to recover 5, and we are defining what is the reference data frame and the target data frame. The target is our search product embeddings, the 10 records that we want to get the recommendations for, and the universe of products to recommend, which is the reference table, or the product embeddings, which have the 6,000 records. Since I have already run this code before, I have already a table called vector distances where I have the vector distance data, and I'm loading that one into a data frame so I can show you very fast what were the results of running the code. Let's look at the shape. We have 50 records. Now, why we have 50 records? That's very simple. We have 10 products in the search product embeddings table, which is our target table, and we're retrieving 5 recommendations per each product. 5 times 10, 50 records, and we have 5 columns. So we're going to get a view of the data. We have the vector distance that we have mentioned before, and we have it sorted by product ID only for one of the products, which is the first 5 records, and then we sorted by distance. And you can see here that the distance in the first case is very minimal. It's very, very, very close to 0, this distance actually. And that is because that's comparing the product to itself. We have the set of 10 records that we want to get recommendations for, and we have the entire universe of products that we got the embeddings. And of course, this one that we want to get the recommendations for is a subset of the universe of products. There is a comparison of a given product ID to itself, and of course that vector is exactly the same, so it's going to be close to 0, and we get all the other products that are related to it coming down. But the way that we are seeing them here, we can just see the product IDs, but we cannot see what products they are being actually related to or recommended. For that, we are going to run to the next part where we're going to get the final recommendations. Here, we're setting up a function that is just performing all the joins. So we're getting the product names from our product table and getting that merged with our vector distance df that we have created over here. And we also need to join the product names from our search products data frame. And when everything is merged on the product IDs, then we are going to have the results, which is a table that is going to be similar to this, but that is going to have the product names. And let's run this code that we just created. And I would like to sort it by product ID again. And here it has another name, so we're going to call it search product ID. So we have our table here, and as you can see, we have the pomegranate gummy bears are related to watermelon gummy candy, of course, pomegranate hard candies, of course. We have also a relation to gummy bears themselves, organic gummy bears, and so on and so forth. This type of recommendation system would be useful for a store where you are recommended products based on your previous orders. For example, you already bought a lot of gummy bears in the past, or you're going to get recommended gummy bears. If you have been paying attention, you notice that in this result table, we are getting only 4 recommendations per product ID. We are not getting the 5. Because you remember one of the recommendations was the product itself. And the reason why is because in one of these lines of code, we have eliminated recommendations where the distance is less than this amount, so that will eliminate all the comparison of products with themselves. And this will give you a data frame that actually we display the shape is going to be only 40 records long, because we have eliminated 1 record per recommended product. So let's check it out. Yeah, as you can see, 40 records. There are ways in which you can graph the results. I want to give you a little bit of homework. You're going to take a look at the heat map, and I want you to find how this graph represents concepts that we have been discussing. That's something very interesting to do, that you can do at home, and that you can use to cement the knowledge that you're getting. It is also possible to display recommended products in Markdown, which is what we have here. There is also an option to select the product from a widget. This is fun to do, so we're going to run that one. And we have it here, ginger snacking cookies. We have all the cookies that we have checked, but we have also the milk chocolate minis, and we'll give you this kind of experience. This is just a little widget that you can have fun with. Of course, you can also have more sophisticated use cases like the real-time recommendation here, where you are using the embeddings directly when you select a product. So it's kind of like doing it in real time, integrating the OpenAI API when you are performing a search, for example. This is quite cool, but I don't think we are going to go through this one right now. Also, it requires an OpenAI API key, which you can acquire with them if you decide to implement this. Having checked everything out, let's clean all our work tables and we will be done. Thank you very much, everyone. I hope that you have enjoyed this video. Of course, if you have questions, leave them in the comments. We are going to try to come up and answer to you. Also, if you have questions about this, feel free to join the community. Leave us a question in the ClearScape analytics area of our Teradata community. And most important of all, what are you waiting to open your ClearScape Analytics Experience account and learn AI with Teradata, the trusted AI company? This is Daniel. See you in the next video.